Hi guys! As you know, Creality has lots of different 3D printer models on their portfolio. In this video, we will test one of the printers from the Ender 3 series and which is user-friendly and can print fast. We are talking about the Ender 3 V3KE. So, do you want to know all about this 3D printer? Then stay tuned!
Hi guys, welcome back. My name is Rui and this is the Rui Raptor YouTube channel. If you want to help us out, you can by giving this video a like and subscribe the channel. You can also help by joining our Patreon page or by clicking on any of the affiliate links posted below in the video description.
Hi guys, welcome back. Today we will test and review the Creality Ender 3 KE. The announced main features of this printer are the quick and easy assembly, which includes an automatic self-test once the machine is powered on, its faster speed when compared with other bed slinger models, a nice and smart user interface on its touchscreen, the ability of being controlled and monitored from anywhere thanks to the included Wi-Fi module, the use of linear guides on the X-axis, linear rods on the Y-axis, and dual lead screws on the Z-axis. The printer runs on a direct drive setup and it's equipped with dual-layer cooling fans, leveling sensor, and a sprite hot end, capable of printing up to 300 degrees C. Okay, we will check all that in detail later on, but first, let's start with the unboxing. Inside the package and at the top, we have the user manual and a bag with several accessories. In this bag, we have some screws and tools for the assembly, pliers, a flash drive, a needle to unclog the nozzle, and lubricant. In this top layer, we also have the display, the power cable, the filament spool holder with a filament runout sensor already attached, and a PLA sample. In the second layer, we have the top and bottom halves of the printer, and be careful when taking them out of the box because both parts are connected by cables. And here we have everything that came inside the package.
Okay, let's start by analyzing the printer's electronics, and to do that, we need to open the base of the printer. To open it, we need to remove the bottom panel, so we need to turn the printer base over and support it to prevent damaging the heat bed. Then we just need to remove these 8 screws and we can access the electronics. While removing the bottom panel, we need to disconnect the cooling fan that is attached to it before fully removing the back panel. The board is from Creality. It's a 32-bit board equipped with a GD32F303 microcontroller and TMC drivers for some of the axes such as the X and Y axis. This is the same board used on the Ender 3 SE model. But the difference is that on the KE, there is no SD memory card slot. The base is also the same for both models, and there's even the cutout for the memory card at the side. For the KE, Creality covered that opening with a sticker on the outside. The power supply on this one is a 24 volts and 14.6 amp model. Although the base is all made from plastic, there's a metal structure in the middle to increase the stiffness. The assembly is very simple, and we start by securing the top of the printer to the base with 3 screws on each side. On one of the sides, there is a connector that we need to pass through. The cable is then connected underneath the printer. The display is attached at the right side. We connect the cable to the display and secure it with 3 screws. The spool holder is placed at the top with a couple of screws. The filament runout sensor is then connected. The cable that connects the printhead goes through the top of the X-axis profile and connects to the printhead at the top. We then lock it with the 2 side latches. Next, we secure the cable with the small plastic piece and 2 screws. The X-axis stepper motor also needs to be connected. Once all the cables are connected, we secure the main cable to the structure where the sticker is. And finally, we connect the Z stepper motor. And this is how the printer looks like. The Ender 3 KE is almost the same as the previous SE version but better equipped. This one is equipped with a filament runout sensor, which allows the printer to pause the print if the filament runs out. This machine is set up as direct drive, which means the extruder motor is installed inside the print head. The Hotten is a high-flow model that can reach 300 degrees C, allowing the use of more different filaments. The limitation here is that most of the filaments that run at higher temperatures also need to be printed with an enclosure, which this printer does not have. As for layer cooling, this model has a couple of fans for that, one on each side of the print head. At the back, we can see the leveling sensor. This one is a Creality CR Touch sensor. The X-axis runs on linear rails, and it's belt-driven. At the right side, there's a screw to tension this belt. Linear rails are actually better than wheels. The Y-axis moves on linear rods, and it's also driven by a belt. The belt's tension can also be adjusted by turning this screw here at the back. Normally, linear rods are also nice, but most of these machines come with play on these rods, which is far from nice and can cause issues on the prints. And the printer we have is no exception, as we can see the play on the build plate. We made a video talking this issue in more detail, so check it out. The link is available in the description. The Z runs on wheels, and it's driven by a couple of lead screws and one Z motor at the side. The second lead screw is synced by a belt at the top. One curious aspect is on the metal profiles used on this model. On most printers, manufacturers use the T or V-type profiles and the wheels run on these. On this printer, they use this different V-shaped type where the wheels run and therefore have more contact area. Although the Z-axis runs on wheels, they don't have eccentric nuts and don't need adjustment, since that is done automatically. The print volume is 220 by 220 by 240 millimeters. For the build plate, this printer uses a flexible metal plate with a little bit of texture. One other feature of this printer is that it does not have knobs and springs to adjust the build plate. The build plate is fixed, and on the carriage there's a pressure sensor allowing the printer to automatically calibrate the Z offset. The display is touch sensitive, and it has a couple of USB connectors at the side. This means you can plug in a USB flash drive with your files to print and also connect a USB camera for remote viewing. As for the firmware, it runs on Clipper, and you can access the printer and start the prints through Wi-Fi. When turning on the printer for the first time, we need to go through an initial setup. The first step is to select the language. There are several to choose from, including Portuguese. Next, we need to check the box at the bottom to agree with their privacy policy. Then we have the Wi-Fi setup. We can either select the Wi-Fi network and enter the credentials now, or skip and do that step later. Next is to select our time zone. And then is this Creality cloud service that we can set up or skip. Once that is done, we can then proceed with some automatic machine self-checks, such as the nozzle heating check and the heat bed check. Then it will perform a nozzle cleaning and then the automatic Z offset calibration. For the Z offset calibration, it first probes the bed with the leveling sensor and then touches the nozzle on the bed. The sensor that is located under the bed detects the nozzle touching the bed and this way calculates the Z offset value. Once that is done, it will do the bed leveling. On the screen, we can check the values that are being measured. For the bed leveling, the printer probes the bed 25 times in a 5x5 matrix sequence. And that's it. The printer is ready to start printing. And this is the main screen. In here we can see the current nozzle and bed temperatures. There's also a graphic showing the temperatures along the time. There's also an icon for the Wi-Fi status and a button to turn the layer cooling fan on and off. On the second menu, we can move the axis in 3 different step lengths and home the axis. At the top, there are 2 additional tabs. On the first one, we can heat up the nozzle and push or pull the filament. And on the third tab, we can turn on the layer cooling fan, adjust the Z-axis compensation, the print speed, and flow percentage. On the third menu, we can load the file to print. We can load from the internal memory, from the USB drive, and check the print history. On the fourth menu, we can do several adjustments such as the screen brightness, display time, language, sound on or off, run the equipment self-tests, input shaping in case you have a vibration sensor connected, time zone, and bind the Creality Cloud. Through here, we can also check if there's any firmware available online and install it directly. And finally, the restore option. On the second tab, we can select the Wi-Fi network. And on the third tab, we can access the camera settings in case you have a USB camera connected. On the last menu, you can access some links for help. And on the second tab, we can access the log files. Okay, it's time to start printing and test the printer. For the first test, we used PLA and printed the benchy that came already sliced in the USB flash drive. For the following tests, we sliced our own benchy and printed again. For the slicer, we used Orca Slicer. Although you can access and send the files to print through Wi-Fi, you can't do it with Orca Slicer due to the Clipper version that this printer has installed. For that, you can use Creality Print Slicer, which is similar with Orca Slicer and can connect to the printer. To do that, we only need to do a search in the Device tab for our printer and then add it. If you prefer to use Orca Slicer or any other slicer with this printer and access through Wi-Fi, you need to first root the firmware and install a different Clipper version. If you want to know more about rooting the firmware, we have a video explaining that. In that video, you can also learn how to check for firmware updates and how to install them. We also sliced and printed the benchy with different materials, such as PETG and ASA. We also wanted to test TPU filament, and for that we printed a vase. We then printed more models in PLA, such as this elephant. And this multicolor vase done with Sunlu's filament connector. Okay, let's see how the prints turned out. The first one is this benchy that was already sliced and came in the flash drive. It came out nice, but we see some defects on the face and edges of the cabin. The top of the front window also shows a bit of hanging issues. The one that we sliced, on the other hand, is a lot better. We cannot find the issues that the first one had on the cabin and top of the front window. Although it's better, it's still not perfect. The surfaces are not perfectly smooth, which can be caused by the missing vibration sensor and play on the Y-axis. The benchy printed with PETG also does not look bad, but shows the same signs on the surfaces as the previous one. As for stringing, it's just a very small amount. The benchy printed with ASA filament also turned out nice, but again with the rough surface as all the others. Because of these results, we made a couple of test cubes and sliced them on Creality Slicer and Orca Slicer. The one printed with Orca Slicer shows more ripple effect, which means that the profile that we can find on Orca, it's not perfectly dialed in. The cube sliced on Creality Slicer is better. On the x-axis, the walls are much smoother, but on the y-axis, it's still a bit rough, probably because of the play on the rods. The elephant printed with PLA and sliced on Orca came out much better than the Benchy. The walls are smoother, probably because it's much easier to print since there's less movement transition. The vase done with the filament bits joined by Sunlu's filament connector came out okay. However, if we take a closer look, we can see a bit of salmon skin effect on the surface. We did this print again, this time with a different filament color, so we could see it better, and it confirmed. The salmon skin effect is also present on this vase as well. As for the TPU prints, we made a couple of vases. First, we did a small one, which turned out great. The TPU is very flexible, and the extruder had no issues printing this filament. We ran this model again, but much taller, and the printer did not have any issues printing it. Okay, and now for the pros and cons. On a positive side, we have the super easy and fast assembly. It's much easier and faster to assemble this model than, for example, the older Ender 3 model. It's equipped with a filament runout sensor, a CR touch leveling sensor, and the Z offset sensor. The non-existing springs and knobs on the bed eliminate those boring manual initial adjustments, since they are all done automatically. This is also a good help for the guys that have this one as their first 3D printer. It's a direct drive printer equipped with a good high flow hot end. The use of linear guides and linear rods are a plus as well. However, the linear rods don't have the exact diameter, which causes play on the y-axis. Better quality rod manufacturer, or at least implementing a quality check at the Creality factory, would prevent this from happening. It's equipped with a 4.3-inch touch display with nice user interface. Although the touch display is nice and the menus are user-friendly, sometimes you need to slide up or down through the menus, and at those times, the touch display is not responsive enough. The firmware, which is Clipper-based, and includes several nice features such as the new firmware version detection and automatic firmware installation. The firmware also allows enabling root access for the guys that want to install additional stuff. It's possible to add a camera for remote monitoring and also a vibration sensor to reduce the ripple effect. The higher printing speed and acceleration is a good feature. However, without the vibration sensor, you will not be able to get better print quality. This is a $12 component, so it does not make sense to have it sold separately. Creality and the users would benefit a lot more if the vibration sensor would come included with the printer already. The printer also includes a Wi-Fi module, which allows you to send the files to print directly from the slicer or from the cloud. However, for the Wi-Fi access, you need to use Creality Slicer to be able to connect to the printer. There is a possibility to connect using the browser or other slicer such as Orca Slicer, but to do that, you need to root the printer and install a different Clipper version. You can also install Creality's app for your smartphone and monitor your printer from there. The Creality Print Slicer is also a good thing not only because it works great and it's similar with Orca Slicer, but also because it comes with the profiles for this printer. And on the negative side, we also have, although the print quality is not bad, it would be better if the vibration sensor was included and if the play on the rods wasn't there. And we also noticed some salmon skin patterns on round models. So, in conclusion, this is a good printer for every beginner in the hobby because you don't need to worry with some of the initial adjustments and calibrations since they are automatically done. It's also a decent choice for more experienced users due to all the nice features, and the price is at the right range for a printer with these specs. The downside is the fact of the play on the rods and the vibration sensor that is not included. So if you plan on buying this printer, check your rods and order the vibration sensor because it's a must. And that's it, you guys. Thanks for watching. We will see you guys next time. Bye!